गाड़ी लेके सब बड़ा
Scatter. Scatter.
Okay, let's get started then. Good afternoon, everyone, and welcome to Venture Center. But before getting into the event, let me take a few minutes just to quickly introduce Venture Center, and then we'll get started, right? So, as you know, some of you know already, but for many of them which are probably visiting us for the first time or joining online with us for the first time, so we are a deep science and technology-based business incubator approved by Ministry of Science and Technology, Government of India. We are structured as a not-for-profit independent company hosted by CSIR National Chemical Laboratory. We were founded in 2007 and has been recognized with several national and international awards, the latest being the National Award for the Incubators for Nurturing IP. All right. So it aims to nucleate and nurture knowledge-based enterprises, and it does this by creating and maintaining a very rich innovation ecosystem. And we empower scientists, engineers, clinicians, and any knowledge workers to help them transform their innovative idea to market-ready solutions. And these are some of the sectors through which we are supporting our startups. This is an example of technology leadership, which is based on diverse and cutting-edge innovations, starting from bio-CNG production to climate-resilient crops, to US FDA-approved spinal implants, to CDCO-approved diagnostic solutions, to drones technology, to process modeling and simulation, and the disposable bioreactors, which are right now showing technology leadership. Very quickly, we have supported around 800 plus startups and innovators across our various incubation programs. And the startup supported via current incubation program has raised already 700 crores of risk capital, 1,700 crores of revenue, and 27% of founders are women. And as you can see, other data, like they have filed some 140 unique patent families, and most of the companies are working on product-driven solution. This success has been made possible only through via an open access ecosystem that supports startups with comprehensive resources, which includes mentoring, continuum of funding. It also includes testing facilities, characterization facilities, information resources like libraries, and regulatory tech transfer IP support system, and very large scale programs are also being run by Venture Center to support our startups. This is compilation. This particular compilation features our current and recent graduate resident incubatees. As you can see, over 50% are into healthcare domain, more than 15% into sustainability, clean energy, 14% into agro, and remainders in other sectors, including digital automation and several others. Our reach is now pan-India, and it's not only pan-India, our associationship with our partners are also goes beyond the boundaries of India and in other foreign locations as well. And thanks to our board of directors, thanks to our government and agency partners, our CSR partners, and I would definitely like to end by just showcasing some glimpses of resources and facilities that we have developed over the years. So anything that you wish to know about Venture Center, these are our contact details. We'll be happy to address any queries you have about Venture Center or anything else that you wish to know about us, right? So let me just stop my presentation for Venture Center here and come to today's talk. So once again, welcome to all of you for the 19th talk of the NCL Innovation Seminar Series and panel discussion on clean hydrogen challenges, opportunities for innovations in India. This is organized by two major programs of Venture Center. One is Center of Excellence supported by DST, and another is Center of Excellence on Clean Energy and Green Hydrogen. This is also organized by Pune Hydrogen Valley Foundation, which is India's first Hydrogen Valley setup with the support under DST's Hydrogen Valley Innovation Cluster and NCL Innovations from CSIR NCL. And it is generously supported by Thoughtworks Technologies India Private Limited, which is our CSR partner. So now coming to today's talk, we are very pleased to have with us Dr. Ashish Lele, and we welcome him with probably a round of applause, please. Let me formally introduce him before he can get started with his talk. So Dr. Ashish Lele is the Director, CSIR National Chemical Laboratory. He currently provides thought leadership for several major initiatives of Government of India, and especially the initiative that I just now spoke about, which is the National Hydrogen Energy Mission. He was previously Senior Vice President and Head Advanced Materials and Alternative Energy Group in Reliance Industries Limited. He has extensive research and technology development experience in alternative energy systems with a particular focus on hydrogen energy, new manufacturing paradigms for chemicals, materials, structure, processing, property performance relationships in polymers and advanced materials. Dr. Lele holds PhD from University of Delaware, USA, and is a distinguished alumnus of Department of Chemical Technology, University of Bombay, the then UDCT and now the ICT. He also is trained at the University of Cambridge, UK. Dr. Lele is the recipient of many prestigious awards, including the Bhatnagar Award and the Infosys Prize. He is a fellow of Indian National Academy of Science, Indian Academy of Sciences, Indian National Academy of Engineering. So with this brief introduction, I would request Dr. Lele to come here and take the charge of the podium. Instructions for online. Just before the talk begins, few instructions for the online participants. First of all, we would request you to maintain certain discipline and not switch on your audio or video in between the talk. Please post all your questions in the chat box. Please be ensured that all questions will take up probably during the panel discussion that is followed, and where we are going to meet a panelist in the form of investors, technical experts, and Dr. Lele also will be available. So please keep posting your questions in the chat box. And we are also streaming this live on YouTube. So participants who have joined the YouTube, request you to also keep posting your questions. We'll take that up during our discussion. So with this, I would just request you to get started.
Yes. Right. Thank you, Shoma. Always a pleasure to be. Yeah, great. Always a pleasure to be at Venture Center. This is home for me, so it's coming home multiple times. So much has been said about this topic. When I started thinking about what I should say, so much repetition. I thought I will spend a little time on topics that are not usually covered. So while there are slides that are the typical slides that you will see and hear in most of the presentations on green hydrogen, I'm going to try and skip many of them or just rush through them and focus on those slides which I think are reasonably new. The thought process, the thinking is also new. And particularly because I think some of them would be very relevant to India. So that's the plan for today's talk. So as the title says, focus on challenges and opportunities for this clean energy vector in India. Yeah, something like
I'll change it.
no, I don't manage. Right. Okay, so that's roughly how the contents are going to look like. Very brief background, and then come straight to leave that for a moment. Yeah, what is hydrogen status in India today, and what we think could evolve as we go along in the foreseeable future. And then coming to the main part of the talk is the challenges and opportunities in all parts of the hydrogen value chain, the production, utilization, and storage and distribution. But in today's talk, I will mostly focus on the production part, because this is where India is heavily focusing on. The utilization bit will come a little later, and actually the biggest problem in the hydrogen economy is storage and distribution. But I will purposely not focus too much on it because a lot has already been said in it. I maybe have 1 or 2 slides on that, but so primary focus is going to be on production. Okay, and of course I cannot end the talk without showing what we are doing in CSIR. So as time permits, I'll spend a couple of slides on the CSIR's activities in this domain. So let me start with the background, and this is a general slide. You've seen this many times, so I will rush through it. As an economy, we are hoping to go to about $5 to $8 trillion, but all our energy demand comes from imported carbons. And as a result of it, we are emitting a large amount of CO2. We are the world's 3rd largest emitter. And therefore, to fuel our economic growth, we have to resort to clean energy. And also, at the same time, because of all the disruptions in the global supply chains that are happening, we have to the extent possible, ensure that we are as self-reliant as possible. So multiple options are available today. First and foremost is do simple things like improve energy efficiency. Changing CFL to LEDs have done miracles, and there are such opportunities which are available across many domains in improving energy efficiency, and that is the lowest hanging fruit. We are already on the verge of on the path of increasing our installed capacity for renewable energy, and that's clearly something that we need to do. Valorize agro bio waste as much as possible. Talk about it a little later. Many energy storage options are available today. While the world is focused on batteries, India is spending a lot more efforts into pumped hydro, and which is exactly the right thing to do. Batteries will come a little later, but pumped hydro is something that we can significantly improve upon. And last and not the least is the nuclear energy. I'll talk a little bit about it. So as we do this very massive and very difficult energy transition, going from about 85% or more of fossil-based energy supply to about 50% non-fossil-based energy supply. That's a massive transition and extremely difficult transition. The greatest difficulty is that this has to be done at a speed that we have never done before. We don't have much time left. So like every country is focusing on how to do this energy transition. In the COP26, our Honorable Prime Minister listed 5 things that India will do. These are national commitments now. I will not read all of them. They are written there, and I'm sure all of you have seen them. What I do want to say about is that table. And if you look at the total emissions sector-wise, power, for example, is the largest emitter. But the last two, the energy, the industry and the heavy transportation, are 2 sectors where typically people prefer to use molecules rather than electrons. So while power can move to more electron-based, electricity-based, that is solar, wind, and hydro, and so on, in industries, people like to use molecules. And you want to use as green molecules as possible, right? And in heavy transportation, people want to use fuels which are molecules. Although current trends are moving towards electricity, but some of these sectors, especially the heavy duty transportation sectors, which are long distance, heavy load carrying vehicles, still prefer to use hydrogen, to use fuels. And therefore, these are the 2 sectors where, like everybody else in the world, we are also trying to focus on using cleaner molecules, and hydrogen therefore comes as one option that is available for us. So much of the utilization of hydrogen, like anywhere else in the world, in India particularly, is focused on the use of hydrogen in industry and heavy duty transportation, in that order: first industry and then later heavy duty transportation. So why hydrogen? Of course, is because it's what is called a sector coupling energy vector. Big terms. All it means is that you can make hydrogen quite easily with reasonably high efficiencies from electrons through processes like electrolysis. So you convert electrons into molecules. That hydrogen can then be used in multiple sectors. So you are coupling power sector to other sectors which are industries. It could be chemical industry, metallurgical industry, transportation, and so on and so forth. So it couples power generation with many sectors which are used sectors. And if required, this is not really a great option, but if required, you can use hydrogen to produce electricity back by technologies like fuel cells, where hydrogen is used to convert chemical power into electrical power. The reason I said it is not very useful is because the round trip efficiencies are quite low. For example, an electrolyzer is about, let's say, 70% efficient on the conservative side, and a fuel cell is about 50% efficient on the conservative side. And so that's about 35% efficiency. So round trip efficiency is not that great, but there are cases where that is required, where hydrogen converted into electricity is required in multiple cases. And if time permits, we will look at some of them. So this is the reason why hydrogen is called a sector coupling agent, and it is clean, of course, because provided, depending on how you produce hydrogen, you have very little emissions coming out, and therefore it's a clean energy vector. Some of the numbers on the right-hand side are interesting numbers and worth always fundamentally important numbers to be kept in mind. It's a very light gas, very low molecular weight, only 2 grams per mole. It is a very low density gas. It occupies almost 10 normal meter cube for every kilogram of hydrogen. That's 10,000 liters for every kg of hydrogen. It has a lower heating value of 33.3 kilowatt hours, higher heating of 39.4, an extremely reactive gas. For those who do chemistry, hydrogen is a reductant and a very widely used reductant. And it has a negative Joule-Thomson coefficient, okay? Which means that if you expand hydrogen, it doesn't cool, it actually heats up. And it has implications on refueling hydrogen, filling it in compressed gas cylinders, and so on. So these are some fundamental numbers basis which a lot of calculations are done and a lot of conclusions are derived. Now, the first question that people ask is why are we thinking of hydrogen today? Because there have been multiple hypes of hydrogen. People found seven hypes of hydrogen, so there's been a lot of excitement in hydrogen, then it dies out. Then again, after a few decades, a lot of excitement, and then it dies out. So why is it? Is it just a hype, or is it to some extent reality? Is the first question. And to me, there are 3 factors why, at least I think, and many agree in the world, that this hydrogen is a reality. Of course, there is hype. There has to be hype in every new technologies that you bring in, but there is some sense of realism as well. And one of the main reasons for that is the cost of chips have come down significantly. The cost of silicon wafers have come down very, very significantly. Some of the numbers are shown there. In the last decade or so, the cost of silicon wafers has really plummeted. There is also some amount of hybridization happened between solar, wind, and other forms of electricity storage and production, and that has improved the capacity factors. And therefore, both of these put together, the levelized cost of electricity has also plummeted. So the cost of electricity has come down significantly. All of us know that renewable energy costs less today than coal power, although it is intermittent. But that has resulted into reducing the cost of production of hydrogen. So this is one major factor. If hydrogen were to be produced using electricity, such as splitting water, the cost of producing hydrogen has dramatically come down. The primary driver, of course, is the graph on the left that is saying that the greenhouse gas emissions are reality today. They are anthropogenic in nature, and therefore the rise of CO2 levels in the atmosphere are a big concern today for every sector, and therefore something desperately needs to be done. The third graph on the left bottom says that as the scale of production of hydrogen increases, the cost of capex for putting up plants for hydrogen, producing hydrogen, can come down and has come down significantly. In fact, those who are following literature on electrolyzers have, I'm sure, seen that recently the cost of manufacturing electrolyzer in China is already at $230 per kilowatt. It is not clear whether it is the stack cost or the entire balance of plant cost, but those numbers are unheard numbers, even if it is stack cost. So the costs are plummeting because the economies of scale have come in. So the capex is coming down, the opex is coming down, and therefore hydrogen is becoming more and more affordable. And since it's a clean energy vector, the decarbonization potential, the decarbonization threat makes it think that this is not just a hype, but it is a reality today. And therefore, there is an exponential growth of projects around the world in hydrogen area. This is a dated slide. This is last year, the Hydrogen Insights document last year. And even last year, we are looking at about $300+ billion investments on projects that have been announced. Although conversion of these announced projects into what has gone through FIDs, the financial investment decisions, are about a third of it. So about $100 billion of FID projects exist today in the world. But nonetheless, this kind of investments in hydrogen technology has never happened in the past. And that's again one reason to say that hydrogen is here for reality now. So let's look at how does hydrogen look like today in India? What is the current status and what do we see as foreseeable future? So as of today, about 6 million tons, not 5, 6 million tons of hydrogen is produced. All of it is coming from reforming natural gas. No problem. Yeah, so all of it is coming today from reforming natural gas, and in India, definitely without capturing that CO2 emissions and doing anything with it. So this is reforming without CCUS, which means that for every million ton of hydrogen we produce, we are emitting at least 10 tons of CO2, 10 million tons of CO2 for that. So it's a massive emission coming out of just hydrogen production. There is also a lot of talk going on for converting coal into fuels. And one of the fuels that people are looking at is hydrogen. So coal gasification to hydrogen is an option that India is exploring. Personally, to me, it's a very, very bad option because all that coal, and in India, the coal is a rather a difficult coal. It has 45, 42, 45% ash content in it. Gasification of that coal is not easy, and it results into huge amounts of emissions, anywhere between 18 to 20 tons of CO2 per ton of hydrogen. So this is really not an option that we should exercise, in my opinion, unless we have a solid CCUS technology that comes in. We have a lot of chlor-alkali plants, especially along the coast, the western coast in Gujarat particularly, which produce about a tenth of a million tons per annum of hydrogen. Unfortunately, this is really very dark gray hydrogen because all of these chlor-alkali plants are captive power plants. They burn coal, to some extent biomass, and all of that electricity produced by burning coal goes into producing hydrogen. And therefore, the emissions there are even higher for two reasons. One, the thermal plant itself produces a lot of emission. Secondly, the chlor-alkali efficiencies are not that great, and therefore there is a, because of the efficiency loss, there is a CO2 emission there as well. One can do reforming with CCUS. It needs a major impetus in the country to adopt and deploy CCUS technologies. Easier said than done. We do not have a single site in this country where massive amounts of CO2 can be sequestered, whether it is saline aquifers or basalt. A lot of R&D is happening. A lot of mapping has happened where are the potential sources for CCUS. There is a lot of scope in India, fortunately. However, major investments are required. And because there is no money you can make from CCUS, nobody is investing today in this technology. So as of today, there is no option for CCUS in India. In the foreseeable future, I do not see over the next few years anything we can do with large amounts of CCUS. Small amounts of conversion of CO2 into methanol and stuff like that is a tiny fraction of the emissions that we are talking about. And therefore, the country is looking at electrolysis as a major option for producing green hydrogen. But of course, electrolysis only when you use renewable electricity. If you do that, then today you can definitely produce hydrogen for less than 2 tons of CO2 emission per ton of hydrogen, much less than 2 tons, if you use all of renewable electricity. I will have one slide on that. And that is only scope 1 and scope 2 emissions. And for good or bad reasons, India has defined this number 2 tons per ton as the definition of green hydrogen. I must tell you that the world has moved away from such numbers. The world has moved away from the so-called rainbow of hydrogen colors. Okay? People do not talk about green hydrogen or gray hydrogen today. People only talk about what is the carbon intensity of your method of producing hydrogen. And therefore, it gives us an entire scale from gray to green, an entire scale of relating or converting the emissions to the cost, right? So I think there is a serious talk happening in India as well in the higher circles to think about should we also follow that path and do away with the colors of hydrogen and just go with carbon intensity. Okay? And I believe that something like that will happen in the near future. So therefore, the MNRE, the Ministry of New and Renewable Energy, were tasked to create the National Green Hydrogen Mission document. It's actually really a wonderful document. It outlines many things, of which most of it is the budget outlay for that for green hydrogen mission, about 20,000 crores. And much of that goes in incentivizing the production of green hydrogen and the production of the manufacturing of electrolyzers. There is also some money allocated for running pilots, for creating hydrogen hubs, for some R&D programs, and so on and so forth. But in addition to the actual mission document, it's equally important to note that there are some important enablers for catalyzing the hydrogen ecosystem in the country. For example, the biggest one is the waiver for interstate transmission of electricity. So you can have solar electricity produced or wind in Leh and transport all those electrons to Tuticorin, the complete down south, and have electrolyzers there. And all the transmission for from Leh to Tuticorin is waived off if you want to use that for producing hydrogen. So this is a huge waiver. And it is important to note that this is possible in India only because we have one grid. Please remember, in many countries, there is no one grid. Australia has 3-4 grids. And therefore, taking electrons from one end of Australia to the other is just not possible. The same exists with US. In India, we are blessed, for good or bad reasons, to have one grid. And because of that, these kinds of waivers become possible. I'm particularly proud to say that my own laboratory has contributed to the policy document itself. Chapter 7.11 states in the document that this entire R&D program of the National Green Hydrogen Mission was developed in consultation with my lab. So we're very proud that we have been able to influence the national policy in this area as well. This is how roughly things would look like in the foreseeable future for clean hydrogen opportunities in India. In the near term, the National Green Hydrogen Mission is aiming for 5 million tons of hydrogen production. About 65 to 70% of it is meant for exports. So it's very clear. The markets for hydrogen are today, they exist outside. Countries like Japan are willing to pay premium price for hydrogen. That doesn't exist in India today, and therefore make hydrogen and export it. So there are a lot of bilateral ties that are already being inked. One between India and Japan is already in place. There are discussions happening for other countries as well. And therefore, export is a huge market for India today. Along with that, one has to create facilities where you can take hydrogen produced on the land, take it to the ships, which are on offshore, and that's bunkering. That is taking fuel from on the land to the ships and fueling it. So storage of hydrogen, bunkering of hydrogen, all of those are clearly the areas of thrust for India. And then a little bit of it, whatever is left, 25-30%, will be used for replacing slowly in a phased manner our own gray hydrogen with green hydrogen. There are difficulties in doing that in India, but we are trying, the country is trying to see how to incentivize this phased replacement. In the midterm, we think that the capacity will be almost double, about 12 million tons of hydrogen, and much of it should go in either fueling transport vehicles on the large roads in India, or using that hydrogen to make fuels which will transport things. For example, the sustainable aviation fuel requires a lot of hydrogen. So converting hydrogen into sustainable fuels is the other way around. So in one way or the other, hydrogen will find its application in heavy duty transportation. This again is based on the fact that 70+% of cargo in India, freight transportation, happens on roads. And you can see, of course, all of us can see how much thrust is being put by the government on increasing our infrastructure for road transportation. So, this is definitely an area that we think will grow. And a little longer term, although the experiments are happening even today, but a little longer term is a large amount of hydrogen will be really used in sectors which need hydrogen, which are really difficult to abate sectors such as steel and cement production. Particularly steel, large experiments are already happening in the country. And we are one of the first countries to actually put hydrogen in a blast furnace. Not 100%, but 5% hydrogen in blast furnace is an experiment that is already being done in the country very successfully. Blast furnaces are mammoth objects. these kinds of experiments are very, very, very difficult, very risky, but they have happened in this country, and it is shown that it actually works. And therefore, these are rather difficult to deploy at scale, and therefore we think it will come a little later down the line. But there is a huge push. Some of the recent drivers for these kinds of experiments are the pandemic and the wars, which both came completely unexpected, disrupted the entire global supply chains, and countries like India, who are not very self-reliant on energy, suffered heavily. You all remember how natural gas prices just shot up, and that was a big problem for the country. Just very roughly, just 2 points that there are other very interesting options available for India. For example, the Great Nicobar Island is an island that is strategically being considered by the country. It's a strategically placed island. The government is doing a lot of thinking around it for strategic reasons. Okay, but it is just opposite Singapore, and Singapore is a huge bunkering port. So if Great Nicobar can be developed as a bunkering port, a refueling port, it would open up massive opportunities for the country. So it's an interesting option worth looking at. And also, you may have heard that there's a national logistics policy that is coming up. It's a complete AI platform on which goods will be transferred from ports to the places where you want to use them. You can book, when that policy is launched, it's thought that you can think of booking a freight from JNPT to Bangalore, let us say, and you will get the best options possible. So the AI platform will tell you how the goods will travel from one place to another, where it will be stored, how long it will be stored, all the dates. So there's a lot of transparency in how things will move, both in terms of dates and cost. Now, something like this, basically what it does is it allows you to transport large amounts of goods in fewer vehicles. So the vehicles become big, distances become longer. And this is exactly the opportunity for fuels like hydrogen. You want to use hydrogen for that transportation, which is very long distance and very heavy, right? So, using national hydrogen logistic policies and, dovetailing it with hydrogen utilization could be a very interesting option that we could explore in the future. So kickstarting of hydrogen economy is happening. I think the PLI scheme of MNRE has been really a great catalyst. And some of these, this has already been announced. There is a tranche 2 that has already also been announced, and then a tranche 3 is coming up. So this is basically what it does is it incentivizes to some extent the production of hydrogen as well as the manufacturing of electrolyzers. And although the scales are not very large, the entire tranche 1 is, for example, only 1.5 gigawatts, and we are looking at much larger numbers than that. But 1.5 gigawatt is a reasonable number to start looking at economies of scale. So all of these companies, they are not pitching only for making electrolyzers at that scale, but they internally are looking at how do I expand my scale? Because once an investment is made and you want to recover that investment, you will have to bring in economies of scale. So all of them will look at scaling up, and therefore, I think the economies of scale is going to be set in because of the PLI schemes. This is a little dated slide. I see somebody sitting in the audience whose name of the company is not appearing here, but this is a little dated slide. Some changes have happened. The other big enabler is standards. And I think over the last few months, I must really congratulate MNRE and many who helped MNRE in making sure that green hydrogen standards are being they are made official now in a very large number. So few years ago, we had no standards really, and within a short span of a few months, we have already adopted about 87 standards for hydrogen. There are about 60 standards under development and some new standards that we are looking at. So having standards is very important, because nobody wants to make an investment if there is no standards on the basis of which you want to deploy hydrogen or manufacture electrolyzers. So standards are such an important thing that, once you have a standard, you can kickstart investments in industry. Therefore, to me, this is a very, very important step that India has taken. And then every state has made some announcements. The government of Maharashtra recently announced a green hydrogen policy. The one that really kickstarted all this at a state level was Kerala. And then many others have joined this euphoria. And so a lot of pilot projects are happening in different states. A lot of investments are happening in states. A lot of incentives are provided at the state level. So all of this really kickstarts the growth of hydrogen in India. And therefore, basis all that, the industries are also investing in a big way. And a lot of announcements have now been made. I know some of them definitely are, already making real investments on the ground. So they're not just announcements; they're actually real investments on the ground, where manufacturing of electrolyzers is happening in a big way. And lastly, the other catalyst for hydrogen economy in India is the Hydrogen Valleys, a recently launched program by the DST together with Mission Innovation. A hydrogen valley, as the definition says, is basically an area, a geographical area, where you set up all the three parts of hydrogen value chain. You produce hydrogen, you store hydrogen, or you distribute it, and you utilize hydrogen. So all three of them put in one geographical place is defined as a hydrogen valley. There are more than 40 hydrogen valleys across the world, probably many more. And so looking at that model, the DST said, why not start looking at creating hydrogen valleys in India? And their call for proposal was very exciting, received more than 100 proposals from across the country, and 4 have been selected, and we are very proud to say that one of those 4 is in Pune. So we'll be setting up a Pune Hydrogen Valley very shortly. But the Hydrogen Valleys basically also tell us that we should improve the TRL levels, even going to commercial readiness levels through research and innovation, build knowledge and capacity across the sectors, do some demo projects which are scalable, and increase public awareness. And as we build the Hydrogen Valley in Pune, you will see that all of these 4 elements will be visible as the Hydrogen Valleys starts operating and getting mature. So coming to the meat of the talk, really, the challenges and opportunities for hydrogen production. So these are rough numbers that are worth looking at. You want to produce 5 million tons of hydrogen by 2030, you would need at least 32 gigawatts of electrolyzer capacity. So this is basis round the clock power availability. If you have 20% power availability, which is roughly the average in India, 20% CUF, that number multiplies by 5, so 150 gigawatts of electrolyzer. That's a massive number. It also requires huge amounts of clean water, 330 million liters per day. Huge amount of solar, wind, the numbers are given there. Land, not so much, about 0.1% of India's land availability, 1% of arable land, $150 billion of investments. But if all of that is done, you could save 30 to 40 million tons of CO2 emissions and a lot of forex saving, because you will reduce some amount of imports of LNG and so on. So these are the numbers that can be little worrisome, but this also creates a lot of opportunities and excitement. So the key challenge for hydrogen production is, of course, cost. Everybody talks about the levelized cost of hydrogen production. So here are some numbers, and there are lots of numbers floating around. Okay, so my number is one of them. But what everybody seems to agree with is that the levelized cost, dollars per kg of hydrogen today, is hovering about $5 to $6 per kg. Okay, this is actually a calculation we did. It's a rough estimate, a calculation that we did for the Pune Hydrogen Valley. We think about $5 per kg is a number that is reasonably achievable. So for 1 ton per day, that is 3 megawatts of electrolyzer, efficiency of about 60 kilowatt hour per kg. You can see that these numbers are very conservative numbers. But the important part is that it's around the clock, and the renewable electricity price is about 4.3 rupees per kilowatt hour. This number you will not see anywhere. PPAs are about 7, 8 rupees per kilowatt hour. So where is this 4.3 coming from? It's because of the incentives that I talked about. The waivers in transmission charges, the local state government giving incentives. So that's how these numbers come down. We're looking at a capex which is very high. I told you China is looking at 230. I'm looking at $1,000 per kilowatt, right? So as these numbers come down, the cost of hydrogen will come down. I have some slides showing that. And let me go to that. So these are rough. The graph on the left is a sensitivity analysis. In fact, both the graphs are sensitivity analysis. The one on the left is rough estimates that we've done. The one on the right is estimates from the Australian roadmap of hydrogen 2018. I will not get into details of all this, but basically what it says is that the price of renewable electricity is the biggest determinant, followed by the capex, and thirdly by the efficiency of electrolyzer. How much energy you want to use to produce 1 kilogram of hydrogen, that's the third factor. In that order, so first, the cost of renewable electricity, second, the capex cost, third, the efficiency of the electrolyzer. So one can play around with these numbers through various things. For example, location determines the CUF and therefore the price of electricity. Different locations in India have different CUFs. If you go to Gujarat at the Gulf, you will have great wind and sun together. You can have CUFs of 40%. If you go to Leh, you can have CUFs of 38-40%. But roughly anywhere else is about 20%. So the location matters a lot. I told about one grid, how important that is. I told about waivers, how important that is. And the capex cost will come down if you start making things in India. Alkaline electrolyzers, for example, which everybody is looking at, there is really nothing that you can't make in this country. Okay, there is a company today in India who's selling polymer that goes to make membranes, which is made outside India. There's a company right here in Pune which makes power electronics, which is exported outside for electrolyzers, right? So there are any number of companies today that make steel plates for with all features machined on it. So really and truly, make in India is entirely possible, and that as the manufacturing starts happening, that will be catalyzed, I'm sure, and therefore the capex costs will start coming down. Here is another interesting scenario. You have two possibilities. Either you have solar somewhere and have electrolyzers elsewhere and transport electrons, or you have solar and electrolyzers together as an integrated plant, okay, and transport hydrogen. And in some cases, it turns out that transporting molecules is easier than transporting electrons. Okay. For example, there are many times the grid is unable to accept renewable electricity. So you have windmills there, but they are not able to produce. I mean, you can't do anything with them. You stop them. You have PV receiving photons, producing electricity, but you can't put it in the grid. You cannot net meter it. So in that case, you have a choice of curtailing that power, which we are doing today, or using that power to make molecules such as hydrogen and transport hydrogen. So sometimes, making hydrogen and transporting it is actually an interesting option. If you have solar and electrolyzer together as an integrated plant, you can reduce all the transmission losses. Okay? Today, at a gate in the renewable electricity plant, it's possible to produce electricity at about 2 rupees a unit, but we buy electricity at 7 rupees a unit. Where is all this cost hike going up? It's all the transmission losses, both in the grid as well as at the local systems. All of that can be avoided if you have an integrated plant. So here is a bar chart that shows you if you were to have an integrated plant that works 24/7, that is, you have a lot of battery because solar is available maybe 6 hours a day, but you want to run the electrolyzers 24/7, so you use massive storage, let's say battery. Or you run the electrolyzer only 5 hours a day or 6 hours a day. Okay, how would it look like? And what is interesting here is the numbers of dollars per kg of hydrogen. Okay, it sounds sort of counterintuitive. If you run the electrolyzers 24/7, the cost of producing hydrogen is upwards of $3 a kg. If you run the electrolyzers only 5 hours a day, the cost of electrolyzers is lesser. The cost of producing hydrogen is lesser. So round the clock production of hydrogen is not always the right way to go. Okay, it depends on location. It depends on whether there's a possibility you can integrate electrolyzers with the solar and wind plants. So I would suggest that you don't always believe everything that is said in the literature. For your own plant, for your own use case, you do these calculations, and sometimes interesting solutions come out of it. The third factor I said is energy efficiency. And there are some wonderful innovations that are happening. So here is one which has come out in some of the best journals that are out there. And this is about an electrolyzer that does not pump electrolyte inside the electrolyzer. Okay. Now, normally you have pumps which take electrolytes and pump them through the electrolyzer. Here is an electrolyzer that doesn't have any pump. What it does is a wicking technology. It sucks electrolyzer from a bottom tank and takes it all the way up. And the reason this becomes interesting is because when the hydrogen and oxygen are produced by water splitting, you get bubbles that get produced, right? And these bubbles will block the catalyst surface. And that is the biggest resistance to produce to complete the circuit. The bubbles become the biggest resistance. So you want to remove these bubbles as early as possible. Now the bubbles exist because there is a liquid electrolyte. Now imagine you don't have a liquid electrolyte at all, right? The gas is just evolved and it escapes, right? And that is what is done here. So on these two electrodes, the cathode and the anode, there is no liquid which is pumped here, right? So this is just gas which is evolving and going out. There's no bubbles that are created. The electrolyte, of course, you need, and that electrolyte is sucked through this capillary action right in the central membrane. Okay, it's a very, very interesting innovation based on very simple and beautiful physics, and the outcome of that is amazing. You're talking today of 72% conventional electrolyzer efficiency. With this one simple physics, you can jack up the efficiency of 98%, right? And that changes the game significantly, because every increase in efficiency means less energy consumed for producing hydrogen, and therefore less cost for producing hydrogen. Some of the details are given there. Again, I will not spend too much time into it, but this is a paper that is really worth looking at. There's, of course, a startup based out of it. This company is called Hysata. And honestly, in my opinion, India must look at these kinds of options. Okay, why follow the world? Let's go with what is the best available outside there. And logically, scientifically, it makes imminent sense to have technologies like this, right? So I hope these kinds of technologies will come into India at some point of time. About energy efficiency, there's one other option, which is high temperature electrolyzer, very high temperature electrolyzer. So these are electrolyzers working above 800 degrees centigrade. So this is solid oxide electrolyzer. And once you have that kind of temperature, there's a big Faradic efficiency gain that you can derive. For example, the graph on the left says that you can achieve a current density of 1 amps per centimeter square at a voltage per cell voltage of only 1.5. Whereas in a conventional electrolyzer, if you want to achieve 1 amps per centimeter square, you have to go to 1.8, 1.85 volts. That difference between 1.5 and 1.8 is all the difference in the world. It brings down your cost of hydrogen dramatically. And therefore, solid oxide electrolyzers give massive energy efficiency benefits. Of course, the cost of solid oxide electrolyzer, the capex is very, very high today. But if you were to bring in the economies of scale, the graph on the right shows you, it's a graph that's come out of very detailed analysis from the US DOE report. And we at CSIR, who are also involved in developing solid oxide electrolyzer, we have done exactly this cost estimation for Indian conditions. And we believe that those numbers are entirely possible in India. And you can see how much dramatic cost reductions are possible. Today, today's electrolyzer solid oxide is about $2,000 per kilowatt, upwards of that. We are looking at somewhere around $100, $150 per kilowatt. Massive reductions in capex are possible with economies of scale, of course. So this is another very interesting option for producing hydrogen through use of energy efficiency. Now, here is an interesting paper that came out just recently, 2024 February. This is a paper that has looked at data, published data, over 7,000 papers in the last 10 years, 7,000 papers, of which it has selected 89 good papers, where good numbers and good economic analysis has been done. They have, from those 89 papers, they have got 832 data points. Okay, and they have done just simple plotting of what these costs look like across the countries, across technologies. So it's really a wonderful capture. And what you will see here is among the various technologies, top left, the electrolyzer, which we have been talking about, the cost will come down to less than $3 per kg in not very distant future. By 2030, we are already looking at 4. By 2050, we are looking at below $3 per kg. And if you look at the region-wise, so the bottom right, you'll see Asia, which is towards the right, has the lowest numbers. Okay, so Asia looks like an interesting option, interesting place where the cost of producing hydrogen through electrolysis also is expected to come down. Okay, about CO2 emissions, I said that if you have just solar PV, you can couple wind with it and only look at scope 1 and scope 2 emissions. We are looking at much less than 2 kg CO2 per kg hydrogen. So this is well within the limits of what is called green hydrogen. However, the moment you add even 5% grid with our carbon emission factors associated with the grid today, okay, the number jacks up to way more than 2 kg per kg, right? And therefore, what is renewable or so-called green hydrogen depends on how much grid you add. You can't even add 5% grid today, okay? Because the carbon emission intensity of the grid is so high today, right? So one has to really worry about, am I producing really green hydrogen or not? That depends on what kind of electricity inputs I'm giving to this. Now, this says that there are other options, okay? And these are slides that are not usually talked about, which I think India should again look at. This is ESMR. This is electricity-driven steam methane reforming technology. There is a technology now ready to be commercialized, and the first pilot scale operation, a really nice paper has appeared. I've given the number here again early this year. Technology is developed by Haldor Topsoe. It's called e-react technology. What it does is it simply, it avoids the fuel burner that goes in a typical reformer. Why is that important? In a reformer, when you react steam with methane to produce hydrogen, about 20 to 40% of the methane that you're using as a feedstock, that methane goes in providing the heat for the reaction. 20 to 40% of methane is used as a fuel to provide heat for the reforming reaction. So no hydrogen is produced out of it, only CO2 comes out of it because you're burning methane. Okay? If you can avoid that, and instead of using methane, if you use renewable electricity to provide the heat for the reforming reaction, that's ESMR. Okay? Two things happen. One is the plant becomes very simple, much simple. Okay? The complexity of that plant, just the reforming plant, becomes very simple because you completely avoid generation of flue gas and all the treatment that you require for flue gas, right? You cannot just emit that flue gas, you have to do a lot of treatment to it. So upstream, downstream, all of that is avoided. So the plant becomes simple, but more importantly, you get better feed utilization because you're not burning the methane. You get very quick startups because with electricity, you can heat up things very quickly. And this technology is so interesting that the catalyst itself has embedded into it electrical systems. So the entire reforming tube heats up within no time. Okay. One of the biggest problems in reforming is to carry the heat from outside to inside. The tubes are about a few millimeters. There are hundreds of tubes in a reformer. Tubes are about a few millimeters in diameter. You are heating from outside. You can reach temperatures of about 950 or so. and there is a 100-degree temperature loss going from outside the tube to inside, 100 degrees, because the reaction is so endothermic, it requires so much heat. Whatever you provide is consumed. So there's a huge temperature gradient inside the reformer, and that is a killer. You can't go beyond 1000 degrees because you don't have good MOCs, materials of construction, to sustain that kind of temperature gradient in the reformer. So you're limited by lower temperature. Lower temperatures means lower kinetics, lower conversions, and all of that comes in. You bring in ESMR technology, the catalyst heats up in no time. You can reach 1000 degrees centigrade with absolutely no gradient in the reformer, in the tubes. Okay, and this has massive benefits. You get very quick startups. You can handle dynamics very quickly. You can go to quick changes in pressure, temperature, and flow rates. As I said, you can operate beyond 1000 degrees centigrade. But most importantly, the specific energy conversion is only about 1 kilowatt hour per NMQ, which is about 10 to 11 kilowatt hours per kg of hydrogen. Compare that with electrolysis, which is what? 55 kilowatt hour per kg. We are talking of 70% lesser energy requirement for an ESMR, right? The carbon emission intensity of ESMR, the only emission, that is of course provided you use renewable electricity, the only emission is the emission associated with the reforming reaction, because you are reacting methane with water, you produce CO2. Okay, so that is the only emission associated. That's 5.7 kg of CO2, just pure stoichiometry, 5.7 kg CO2 per kg hydrogen, which is about 35% lower than the standard SMR, because you're not burning that methane. So there's no CO2 emission from that. Okay. Now, this is interesting, I think, for India, because you can do this on smaller plants. Normally, when you do SMRs, nobody will invest in a small SMR because the capex is very high. Okay? You don't get any returns, reasonable returns with smaller SMRs. This is completely different. This is actually best suited for small reforming reactions. So if you have a biogas plant, this is a great opportunity. You can put a ESMR, use electricity coming from renewable. You can run the reformer for 5-6 hours a day. You can shut down, start up, within no time it will start up. Very fast. If your biogas has variations of methane production, all of that can be adjusted in the ESMR. So these are again new technologies which have just emerged, which we should not wait as a country to let everybody else try and then we will jump into it. I think since we are investing so much in biogas, this is a technology that we should seriously consider. For those who want to see all the detailed results, they're all published in that paper. There's a good supporting information also available, this is an option that we should really look at. Biomass gasification is another option. There are multiple technologies available in this country. I'm showing just one example of technology developed by Professor Dasappa at Indian Institute of Science. There's a wonderful pilot plant that gasifies any type of biomass. He has a way to control the shift reactions post the gasification so that you can control the CO hydrogen ratio. You need different ratios for different things. If you want to make methanol, you need a 2:1 ratio. If you want to make, if you want to do Fischer-Tropsch, you need 1:1 ratio, and so on and so forth. So these are, again, a lot of agro residues are available in the country. You can gasify them and, if required, make hydrogen out of it. Again, my option here is to also try and use that carbon instead of converting all that carbon into CO2 and emitting it and using only hydrogen part. You should also look at valorizing the carbon. Okay, coming quickly to the hydrogen utilization. As I said, India is looking at exporting about 70% of the hydrogen produced to countries like Japan, Korea, and Europe, and so on. And that would mean that we have to have huge storage and bunkering facilities at our ports. We have already, as a country, announced three ports, which will be designated as hydrogen hubs, which means that they will have storage capacity for hydrogen and its derivatives like ammonia and methanol. These ports are the VO Chidambaram port at Tuticorin, the Deen Dayal port in Kandla on the west, and the Paradip port on the east. So 3 ports on 3 different regions of India. There is a Maritime India vision, which basically says that the share of renewable electricity in India should exceed to more than 50% by 2030. So a lot of hydrogen and ammonia bunkering facilities are required. But also there are many things in the port, on the in the campus of the port, which also can be converted into renewable story. For example, retrofit port crafts. There are a lot of crafts, tug ships, for example, that are required, the pilot ships that are required, the Coast Guard ships that are required. So there are many ships, they're called retrofit port crafts. They can all be, so port craft, which can be retrofitted from diesel to hydrogen or ammonia or methanol. There are many trucks that operate on the port. There is a lot of considerations happening today on incentivizing the truck operators on the port to go to greener, cleaner fuels. And on the shipping side, there are very nice opportunities that are emerging through bilateral ties for not just export of hydrogen, but also import of things. For example, we import massive amount of iron ore, okay, for feeding to all our steel plants. And we also import very massive amounts of what are called metallurgical coal, very clean coal that is required in blast furnaces, right? All of these are imported, and people are looking at, can I use ships which are powered by methanol, green methanol or green ammonia, and use that to carry these iron ore and the coal to India. Reason this is important is because you may have heard of a word called CBAM. These are regulations that are coming imposed by Europe, and this says Europe wants to import steel only if it follows certain criteria. And decarbonization of steel industry is one of the most important criteria. And that means not just steel production, but decarbonizing the supply chain for steel. So transporting iron ore, transporting coal also needs to be decarbonized, right? So there are these interesting opportunities that are available by bilateral ties for India. And of course, again, I'm very proud to say that we, along with our partners, have produced India's first fuel cell powered catamaran. This is again a ship which is as I said, a port craft. This is used by, it's a ferry, but also used by coast guards to monitor the waters around the ports. On the other part of the hydrogen industry, the refining and fertilizers are things that are reasonably low-hanging fruit. However, moving from currently hydrogen, the current way that hydrogen is produced, which is steam methane reforming, to green hydrogen has an impact on what is called the gross refining margin, the GRMs. Okay, and so it is not very easy to make this switch today. So unless the price of hydrogen starts to come below $2.50 a kg, pushing green hydrogen into refining and fertilizer sector looks a little difficult. Chemical sector is an interesting option. We have a large chemical sector in this country, especially fine and specialty chemicals. It's a growing industry sector. We're looking at about $3 billion sector today in India and going to about $1 trillion by 2040. We export a huge amounts of pharmaceuticals, agrochemicals, and other chemicals. And here, one of the key reactions in making these chemicals is hydrogenation. You need hydrogen as a reductant, right? Today, all of that hydrogen is gray hydrogen. Today, my estimate of this sector is about 100 kilotons per annum of gray hydrogen is consumed. You multiply that by 50, that is the amount of CO2 emission that is happening today in this sector. And this sector is very, very keen to decarbonize because whatever they produce, 60% of what they produce is export oriented. And in the export markets, there is a pressure for decarbonization. So this sector is a very interesting sector, very unique to India, a low-hanging fruit. They're willing to pay price for green hydrogen, and this is a sector really worth looking at. Aluminum is another sector, rather difficult to deploy, but it's a sector which is important for India. We are the second largest producer and the third largest consumer of aluminum. The numbers of how much this consumption is growing is given, the emissions are given, and we think that there is at least an opportunity for 20% CO2 abatement if green hydrogen replaces in both the calcining and the anode production parts of the aluminum production process. But again, not so easy to deploy. Like steel, it will take some time for this sector to adopt green hydrogen. There are already experiments in the aluminum sector in India happening to start using green hydrogen in both these process steps. Steel making I talked about, and I will not spend time on it, but I just wanted to show you one slide that says how the location matters. So if you look at the keys available at the bottom, it's basically the color bars are the ears, and the horizontal bars at the top and midway, the pink and the gray ones are essentially the levelized cost of steel production through blast furnace, which is the bottom one, and the DRI process, which is the top one. So you can see that depending on the region, the utilization of green hydrogen can at least be started in DRI, okay? Because those bar charts are touching that pink bar that you see there. But it's very location specific. So if you are in Kutch and Gujarat, then you can do that. But unfortunately, DRI is not easy to do in Kutch and Gujarat. Bellary, Karnataka, very much possible, as well as Bhilai, Chhattisgarh is entirely possible. So if you talk to steel industry, you will see why they are more interested in DRI first before going to blast furnace, because it does make eminent sense to replace gray hydrogen coal with some amounts of green hydrogen. I talked about the chemical sector, and the Pune Hydrogen Valley is entirely focused on that, right? The chemical sector for India. So what we are going to do is to produce hydrogen by electrolysis, as well as a new route, which is the bioethanol route. We'll produce that hydrogen, we will store it for multiple uses. Two uses. One is for fine and specialty chemical industry, and the other is for transportation applications, right? So hopefully, if we are successful, you will see the first plant for producing fine chemicals using green hydrogen in India, and 2 buses which will ply on the roads of Pune, hopefully Pune, Mumbai, or Pune, Aurangabad, fueled with one fuel cell based and one hydrogen internal combustion engine based technology. This utilization sector, there is so much that has been talked about. So I really did not want to say the same things that you have most likely heard. I wanted to say something different, and that is about the internal combustion engine. Now, it's difficult for me to say this because I've been so invested in developing fuel cell technology, but it looks like that is not the option of choice for India. Okay, and the reason for that is internal combustion engine technology using hydrogen, which nobody was thinking about just 5 years ago, has suddenly come up in a huge way. So the top left graph shows you till about 2019, people were just barely talking about internal combustion engines based on hydrogen. And from 2019 onwards, every single OEM that you can think of is there on that map. Everybody's looking at internal combustion engine because the technologies have suddenly become very, very interesting. There are 3 technologies on the lower bottom chart. There is the standard spark plug based technology. So hydrogen, like petrol, needs a spark to combust. You have the direct injection technology, which is used in all our cars today. But there's a third technology which is emerging, which is called HPDI, high pressure direct injection, which uses a tiny amount of diesel, 5% diesel, to start ignition. So it doesn't use a spark plug. It uses the compression to start ignition with just about 5% diesel, and then hydrogen goes in and does all the rest of the power production. So these are really exciting technologies that are coming up, and including our own Ashok Leyland and few others OEMs, they are all invested into hydrogen internal combustion engines. Why? Because a lot of good things about ICE technology are shown there. And more importantly, it's not so difficult to retrofit a diesel engine with hydrogen engine. It's not straightforward, not like a garage can do it. The OEMs will have to do it, but it's still much, much lower capex compared to fuel cells, right? So for long distance transportation, it might be the fact that India will choose hydrogen ICE over fuel cell. The efficiency of hydrogen ICE till now is about 40%. Fuel cells, as I said, are about 50% efficiency. So fuel cell still is better in terms of running costs, but with the HPDI kind of technology, they are already hitting 50%. So they're coming very close to fuel cells. The only problem with that is you have very high NOx emissions, which of course don't happen in fuel cells, right? So, so these are always trade-offs between two technologies, but eventually the market determines which technology will be adopted, the price determines it. So it looks like for now, India will adopt ICE. Maybe in the future, we will see. Finally, I think one or two slides on hydrogen storage and distribution. The compressed hydrogen cylinders, major concern is safety. However, as I said, we have already adopted a large number of standards, including many standards for storing hydrogen at 350 bar right now. The standards for 700 bar are under discussions. The approvals are still a little slow. Hopefully that concern will be done with sooner. The second major problem is the cost, because the carbon fibers that are required to make these composite cylinders are all imported today. Hopefully, we will have technology in India, made in India, to produce those T700 carbon fibers. Another interesting option that is available actually is the aluminum liners. So for 350 bar cylinders, you have an aluminum liner. And what is required is a seamless aluminum liner. You don't want any welding in that liner. Okay. Surprisingly, this country does not produce seamless aluminum liners. And so there's an opportunity available for those who want to work in this area to get going in this, because people will start using hydrogen cylinders, especially on roads. Whether it is fuel cell or ICE, doesn't matter, you will need hydrogen cylinders. And therefore, these kinds of technologies are worth looking at. There are other liquid storage options, but none of them have really come to the fore. There is a lot of talk about the LOHCs, and some pilots have happened across continental shipping of LOHCs, but nothing really has come in to compete with the compressed hydrogen gas cylinders. Pipelines is a very interesting option. There are, of course, issues with safety and leakages of hydrogen being pumped through pipelines. The material of construction, because of embrittlement, is a big problem. However, there are interesting options possible. For example, if you were to pump anywhere up to 18% by volume of hydrogen in natural gas pipelines, you don't really need to change anything in the gas pipeline. We have a massive grid across the country to pump natural gas. It is not used to full capacity. To my knowledge, only about 40% of the gas grid is used. The capacity is only about 40%, right? You can mix about 18% hydrogen in it. So you transport a blend of hydrogen and natural gas. And where you want to take it out, there are now interesting technologies available. One such is an electrochemical compressor, which doesn't use mechanical parts to compress hydrogen. It uses electrochemistry to compress hydrogen. Single step, you can go from ambient pressure to 700 bar. If you talk of mechanical compressors, you need 5 to 7 stages of compressors. Here, it's a single step compression. Plus, it can separate hydrogen from natural gas. So you have mixed gas coming in, you send it through the electrochemical compressor, you get pure hydrogen coming out at very high pressure. Very interesting technologies worth looking at. There are, of course, like anything else, pros and cons of each of these technologies, and I can talk about what are the not so good parts about transporting blends of hydrogen and natural gas, but it's a technology worth looking at. Shoma, should I stop? We have panel discussion. Right. So I will not say anything about these slides. We have these wonderful programs that have happened through a special purpose vehicle called the Nimitli. We had teams of various labs and industries working together. The last sentence is important, though. I mean, how much potential we have in this country. It's one example of it. Our entire hydrogen budget for the last, so many years, more than 15 years, is 45 crores. which is 1/10 of US DOE's 1-year budget. 1/10 of 1-year budget. In that, we have managed to go from small fuel cells in our labs to the catamaran that I showed you. Okay, how much innovation we can do? That potential is incredible in this country. Okay, I just want to make that point. So these are all the things that we went from a small single cell all the way to cars and bus and catamarans, and we're very, very proud of this kind of innovation. Okay, we are now into a bigger program where we are looking at all other parts of the hydrogen value chain. I don't have time to go through all of it, but a lot of things are happening across CSIR labs. A lot of good innovations and good technology developments are happening in partnership with industry. Okay, so final slide.
Ashish, can I request you to just briefly speak about some of those in the previous slides so that if there are partners who want to collaborate, they may be able to at least answer.
Yeah. Sure. Yeah. Okay. Sure. So the three green boxes are the three parts of the hydrogen value chain: the production, storage, and utilization. And in each part, we are doing something. So on the green hydrogen production, the major focus is on electrolysis. We are looking at all three types of electrolyzer development. At NCL, we are looking at what are called anion exchange membrane electrolyzers. In SECRI, in Karaikudi, we are looking at PEM electrolyzers. And in CGCRI in Kolkata, we are looking at solid oxide electrolyzers. We are not doing alkaline electrolyzers because that is already a highly mature technology. Okay? So these are the three technologies we are focusing on. And in each of these technologies, as we've done in the case of fuel cell, we also step back and see what are the core technologies that are required to make these technologies. So catalyst, can we develop a process technology to make a catalyst and find a vendor who will manufacture the catalyst? Membranes, can we develop all the polymers and the membranes here and find a vendor who will manufacture them in this country? Bipolar plates, can we develop graphitic and metal bipolar plates, find a vendor in this country who can manufacture them? So it's also the core technologies that are important is also a very active part of what we do. In the fuel cells, we have done all of that. We are looking today at licensing technology for platinum catalyst. We have an excellent catalyst that I can show you all the specifications that match with whatever is the best catalyst available, whether it is Johnson Matthey or Tanaka. We can match all the specs there. We have already developed both graphite and metal bipolar plates, and we have vendors who can manufacture them. We are working with a large company, a large mid-sized company in India. Is the only company in this country which can make Nafion equivalent, a polymer that is out of patents. There is no problem with freedom to operate. And we're working very closely with them, 3 labs collaborating with 1 industry partner to do complete monomer to final polymer film. Okay, so these are the kind of efforts that we put in to do end-to-end technology development. On the storage and distribution side, we have a lab that is today doing filament winding to make 350 bar cylinders already, and next step is 700 bar cylinder. But we are doing 2 more things with it. We are also developing all the safety valves that go with the cylinder. So it's a full piece, not just the filament wound cylinder, but the manifolds, the valves that go inside it, all of that. And also we're looking at using new types of resins, epoxy resins, which are recyclable. So this is, again, a completely new technology that has emerged over the last 10 years or so. And NCL is very, very good at polymer chemistry. And we have resins that are fully recyclable. So I can take carbon fiber cylinders at the end of life, maybe 15, 20 years, dip it in a tank. The resin, it's a thermoset resin, but it will dissolve. It will actually make a thermoplastic, which is injection moldable, and the carbon fibers can be completely recovered. Okay? So we're looking at longer term problems, because if thousands and thousands of cylinders made today, 15 years down the line, you will say, what do I do with them? Because the epoxy only can be burnt, nothing else you can do with it, right? So either you crush it into a powder and fill it in roads, which is such a waste of a T700 carbon fiber, or you do something that makes it recyclable. So we're looking at 15 years down the line and say, what is it that we can do today to make those cylinders recyclable? On the hydrogen utilization side, our focus has been on fuel cells, and we are looking at improving our fuel cell technology. That technology is already licensed. I've already shown you pictures of the car, the bus, and the catamaran. We are now, two things we're doing: improving the efficiency of the fuel cell, and secondly, the core technologies, we are now licensing it out. So as I said, licensing the platinum catalyst technology, the vendors for metal bipolar plates and graphite bipolar plates, so that kind of thing. Unfortunately, we didn't go on the internal combustion engine path. Technologies that we thought were not going to come up, and so we didn't look at it. But this is the risk one takes in technology. Sometimes it works, sometimes it doesn't. Okay. By the way, we are hoping that the catamaran will be launched in Varanasi on the Ganga soon. So we will see some that happening sometime soon. All right, that's what I want to talk about, and I will just leave it here. I will not read anything else. Thank you so much.
So I think that was some talk. It is so informative, so packed. I think I'm sure some of you, like me, will be taking some time to consume everything that we have heard today. And I think we need another talk for completing all the discussions that are still pending. So we have got a lot of questions online. I'm sure many of you will be having questions. In the paucity of time, we'll straight away go to the panel discussion so that we'll also get to hear some of the insights and some of the perceptions from our panelists today. So let me, without further ado, call the first panelist who is going to join us online. This is Sonisha Kukreja, who dives into the deep tech, biotech, climate tech at Bloom Ventures. And after almost 3 years in early stage investing, her world is now filled with all things fundamental, interesting in deep tech. Basically, it's something that makes your brain hurt, and it sounds like sci-fi. It's music to her ears. And prior to Bloom, she also worked with Pravega Ventures, American Express. She has training in commerce from elite college called Sriram College of Commerce. So with this, welcome to you, Sonisha. And I'm requesting my colleague to just help you unmute your audio as well. The second panelist today, we have with us Vasu Guruswamy, who is a co-founder and general partner at Lavani Ventures. Again, this is a deep tech driven impact investment firm. He has 33 plus years of technical and global business operations experience in energy, and he actively mentors several technology startups around the world. He has experience in private equity and venture capital investment, and in his role as ex-MD and current venture partner at CSL Capital Management USA. He has a BTech in chemical engineering from IIT Madras and MS chemical engineering from Rensselaer Polytechnic Institute, New York, USA. Welcome to you, Vasu. Thank you for joining us today. The third panelist, which is the person who is actually on the downstream side of it, and he's utilizing hydrogen, I would like to call Dr. Satyajit Phadke. If you can come and join us here, he's in person here. So Satyajit has over 15 years of experience in materials development for energy storage conversion technologies. He has a BTech degree from IIT Roorkee in materials engineering and PhD from University of Florida in hydrogen fuel cell. And thereafter, he has worked at MIT on high temperature liquid metal batteries, which led to 3 patents that were licensed for commercialization. He continued working on zinc alkaline batteries at Princeton and with a Silicon Valley startup on high power batteries at Material Scientist. He has over 8 plus years of experience in technological consulting on energy storage and conversion technologies. I would also request Dr. Lele to also join the panel here along with Satyajit. And so please welcome again all the 4 panelists here with us today for this panel. And I would also like to welcome Dr. Premnath Venugopalan, who is going to be moderating this session along with me. Dr. Premnath, if you can also switch on your video. As you know, he's a founder director Venture Center and he's scientist at NCL. And I would also welcome him to take charge of the moderation as well. And we would like to start with Sonisha because she has she's little pressed for time. So we'll get her views and then we'll ask others, assuming that Vasu, you still have some time, right?
Yeah,
I'm okay. I don't have an issue. Thanks.
Yeah. Shoma, if I can just comment just a couple of quick things.
Yes.
One, thank you very much, Ashish. That was a very, a thorough talk on all the challenges and opportunities. And clearly, I don't know too many people in India who can bring that kind of depth and insight into the field. I just wanted to also point out that, while we were doing all of this, there were questions on, there were about 50 odd people on YouTube and about 100 odd people in Zoom. That's a limit that we could take in. They all put down several questions, but we, in the interest of time, we'll take them up a little later, or we will get them addressed somehow. So at this time, we'll focus on the discussion. And in this discussion, I've requested Shoma to keep the focus on a little bit on what are the opportunities for innovation and startups, and also on investor perspectives. So I think we'll get started with that. So Shoma, over to you.
Right. So as I said, we'll start with Sonisha. So Sonisha, we know that you have recently published a blueprint on hydrogen, right? And you heard something from Dr. Lele as well. So would you like to start giving us a bit of a summary and what interests you to and excites you to pursue hydrogen as a sector, and what is your investment thesis going to be in future, and also if currently there is investment. So there are many questions. Maybe you can start with the brief summary of your report, right? And maybe briefly I can show that report online so that people, if they wish to later on browse, they will be able to do that.
Sure. Meanwhile, you share the report, probably I'll just quickly summarize why we started probably focusing on hydrogen. So in my opinion, so I look at all things deep tech, biotech, AI, life sciences, climate, etc. here at Bloom. To be honest, I had been tracking this space for a while for some personal motivations as well, because I really like the sector. I really like the innovations that are happening. So just wanted to dive deeper into the sector. That was one of my personal motives. But on the other hand, I don't think so any new or say breakthrough disruptions that have happened in the sector. It's just that there are 2-3 very, very important levers that have convinced most of the investors to just look at the sector very deeply. Number one is probably the overall reduction in costs of renewable energy, and the notion that now most of the industry and most of the investors had that probably gas route can be replaced with electricity in the overall energy equation. So the overall reduction in costs of renewable energy, your cost of electrolyzers coming down. So it's very hard to follow Dr. Ashish's session. That was such an incredible session. But we have seen almost 60 to 70% reduction in the electrolyzers cost in the past 3-4 years. So that has been a big feat. So the entire, again, the notion of replacing the gas route with probably say electricity or other greener alternatives like hydrogen, and then an overall system efficiency that we have been seeing for a while. Government pushing for the adoption of green hydrogen, though not very strict policies or recommendations yet, but probably recommendations of today would be policies of tomorrow, is what I feel. So the overall push that the government has been doing. So all of these factors led us to dive deeper into this area, and then of course we were seeing a lot of startups. Dr. Satyajit, we have talked a lot. So number of startups that we had been seeing in the space. So that is what led us to make this thesis. And overall, probably I'll just tell you what we think as Bloom would be the next baby steps that the industry can take towards green hydrogen, and how the overall funding, etc., is shaped, at least for the Indian economy. So if I just borrow that example of the entire value chain that we have for green hydrogen, you have the production with storage, distribution, and the utilization space of it. Apparently, we are finding a lot of startups in both of the extremities. So we have a lot of startups on the production end. We have a lot of startups on the utilization end. But the middle layer of or as they call the secondary layer of storage and distribution is missing because of very obvious challenges and the more technical challenges to be solved, to be honest. So if we talk about production, hydrogen is a versatile gas. It can be produced from a lot of feedstocks. We have a lot of methods to produce hydrogen. Most of the traction that we have been seeing, at least from an investor lens, would be number one, electrolyzers, and number two, the biomass derived ways of producing green hydrogen. Biological ways also, in a way. Thermochemical water splitting and other biological ways are still far-fetched yet, to be honest. But these are the top three avenues where we are seeing a lot of traction. So in electrolyzers, it's a capex scheme, to be honest. And what we as investors feel is almost 60 to 70% of the electrolyzer value chain would be owned by probably the bigger conglomerates like Reliance, Adani, Ambani, etc. So every electrolyzer that you put up requires millions and billions of capex involved. Alkaline is a gone story. Now you have PEM, solid oxide. PEM again, it uses very crucial raw materials that need to be imported. Solid oxide offers us that advantage that at least the raw materials that are used in the electrolyzer stack are cheaper, but then again it involves it requires very high temperatures. So you always have these commercialization versus innovation trade-offs, and this is what we as investors have to look for very carefully. Of course, we cannot go into this much depth as Dr. Ashish explained, but that is also maybe in a way the crux of the entire funding landscape. The more the investors understand something, the more the investors can see, ठीक है, यहाँ से पैसा आता है, this is where we can make money, this is how businesses are built, and it's all golden for us. So how do you make money? How do you build businesses? It's very simple. Just make your consumers adopt your technology. Why would your consumers adopt your technology? Either it's a push from the government, it's a mandatory policy from the government, which is not the case in India. Then probably that you are offering a better technology at par prices, if not lower than the existing technology, and the consumers would jump on your technology. That the technology that is supposed to be the technology of the future. So keeping that business sense in mind while being swayed away by all the technological disruptions that are happening is quite tough, but it's an IRR game for us in the end. Storage distribution come with their own challenges. Hydrogen embrittlement is probably one of the biggest ones. Then for shorter distances, probably liquid hydrogen would be the way to go, is what I think. For longer distances, of course, it's the pipeline, but again, we have to upgrade our pipelines. Some innovation would be happening there. Not a very VC investable sort of business. So what we are betting on is most of the hydrogen that would be produced will also be consumed at the same location because of these given challenges of storage and distribution. And that is why these are the two segments that probably we would like to stay away, at least in the coming 4-5 years. Utilization is on the other end of the spectrum, where we have all these hydrogen fuel cells, and of course, H2 ICE is probably much more adaptable in a way, more commercialization. They are just at the commercial tipping point versus probably hydrogen fuel cells. But again, hydrogen fuel cells is the technology of the future. So that again, we have to balance it out. So as investors, probably we would like to see much more pilots going on, much more production and consumption happening. I have talked to so many startups where the production is happening since they are operating in the production spectrum, but nobody is there to even use that hydrogen to adopt that hydrogen in a way because of the existing infrastructure that we have and the entire upgradation that we require, or probably the replacement that we required. So more R&D needs to go in. Hydrogen Valley is an excellent concept that is being followed in the US, EU, etc. So India still lacks that, but I guess we are on the right track, is what I've realized after making this report.
Can I just ask a quick question, Sonisha,
Sure.
which is what is really the size of the investment pot in such sectors in India? And what are you competing against if you're in the hydrogen business, right? Like
Sure.
what are the other alternatives you look at, compare with, and consider whether this is worth investing in or not?
Sure. A very, very interesting question, I must say. So I would answer the first part of it. The investment sizes, probably it depends a lot on the kind of applications that we are seeing. The lower hanging fruits and the segments where I think probably startups are bound to win are, say, solutions like analytics, very basic analytics. So instead of building the entire electrolyzer, you build just the electrolyzer tech stack. Or probably you help in remote monitoring, or you help in optimization of usage of electrolyzers, or optimization of usage of grid. So these are some of the analytics digital sort of solutions that we are seeing, where the average check sizes come out to be in the range of 2-3 million for the first probably pre-series A sort of ranges that we are seeing. But if you get into proper biomass sort of biological ways of production, we are talking to startups who started off with a raise of probably 10 million, and now they are going as high as 30 million for the very first raise. So we understand it's a very capex heavy thing, and investors do understand that.
This is an Indian number that you're talking about.
This is an Indian number that we are talking about.
And how many such VCs exist who are interested in this space? Do you think is this really a trend, or or you're one of the very few VCs who are really interested in this space?
So, Dr. Prema, I will be very honest with you. Green hydrogen is probably the beautiful, new beautiful girl in the town where every investor wants to date her. And that's just the motive I see probably for a lot of VCs. It's just hot. It's just happening in India right now. So that is why a lot of VCs are joining the bandwagon. But for such $30 million raises, it's mostly strategic players that I've been seeing, to be honest, coming in the picture. Most of the traditional VCs are still betting on the tech first digital things or probably very niche applications where, say, the Adanis and Ambanis of the world just can't renew because economically it just doesn't make sense for them to enter into those areas. So, biomass example, that is one of the things that I've talked to a lot of folks at Adani, and they say that biomass as a sector in terms of unit economics doesn't make sense for Adani. So such very, very niche applications is somewhere I think startups are bound to win. And otherwise, if you're getting into the proper electrolyzers, capex heavy place, 20 million is something that we see would be at least the first or the second round for them.
Thank you. Thanks a lot. Shoma, over to you.
Yeah, so I think from here we would like to also hear Vasu's thoughts on similar points. So Vasu, if I can now request you to also comment, like what factors do you think would make hydrogen attractive opportunity for investment if you wish to consider that sector, and how are you going to evaluate the potential success of hydrogen technologies? Why would you think this is the next best alternative for clean energy and not compared to others that already exist and going to come up?
Yeah, thank you, Soma. Thanks to Dr. Ashish also for this fantastic, we all drank from the fire hose. I've listened to it before in the IIT Energy Consortium, which from our background. So this is always rich with information, fantastic. And Punisha, thank you for elegantly putting many of our thoughts, from the VC community. As investors, the molecules because kind of differentiate from the typical sectors used so broadly these days.
Yeah.
So,
Vasu, your sound is a little off.
Is it?
Would you be able to either keep
Yeah.
the mic
Is it
closer
better
to
now?
you, or it's a little still low in volume. Okay.
Yeah, I'll
Try
try.
it. Yeah, this is much better now.
Yeah.
But
Okay.
go ahead.
Yeah. Probably the mic was a bit getting stuck in my
Yeah,
collar.
now it's great. Yeah.
Yeah. Okay. So, talking about hydrogen, I think many key points have all been mentioned. So I don't want to repeat, between the three boxes that were shown: production, and then storage, distribution, and then utilization. As an investor, I think the first thing that we look at is the market. In this case, what is the market? What is the offtake of hydrogen? What is the demand in India? And this, in some ways, is a bit of a challenge because of the earliness. It's very young market. There are many reasons. The economics obviously plays a very big part. But I would so what I would like to add, in fact, we are thinking about it, and I would like to actually place it on the table. To my knowledge, there is roughly about 800 or 900 startups worldwide which are dealing with hydrogen. Okay, ballpark figure. Some way or the other, they are touching the hydrogen value chain and trying to find solutions in all the three boxes. But if you think about this thing, one of the topics that is of very great interest to us are hydrogen sensors. Okay. And believe it or not, we are able to find maybe hardly 10 startups in the world looking at hydrogen sensors. And there are reasons for it, because actually, if you think about hydrogen, by its very nature, there's a huge technical experts assembled here. The lightest element, leakage is a problem, embrittlement, pipelines are problem, storage is a problem, handling hydrogen, the balance of plant is a huge challenge. sensors play a very, very important role because of the combustible property of hydrogen also. The moment oxygen is there, flash, it's a fast flame. So a lot of challenges are there. And for a country like India, with the problems that Sonisha, nicely identified, the capex demand and all that, if you think about hydrogen sensors, I believe that this can actually be a sweet spot for the areas that we would like to find entrepreneurs attacking, a topic that we would really love to see, because it kind of fits into it's not capex heavy. Yes, it's R&D. Yes, it's got to meet certain standards. In fact, Department of Energy US has set up some standards for the hydrogen sensors. And by the way, I don't think any company is anywhere close to it, the current existing sensors. This is based on our knowledge. I'm sure that things are changing all the time, and some of the experts may know companies which are making progress. This is just one example in this value chain. But coming back to why is this attractive or not attractive compared to other, let's say, solutions or other renewables and the green world that we are looking at. Everything has its place. Each one of these definitely has its place. And as Dr. Lele in the beginning mentioned, transporting molecules sometimes is far more efficient than transporting electrons. But these are specific applications where we believe that the need for hydrogen with its clean combustion properties is going to play a very critical role. And therefore, as long as those markets are identified and the solutions are being developed addressing those markets, I think we have an excellent possibility. It is not going to be a general, one solution that fits all kind of a world. No, it's not going to happen. And he also talked about ICEs. That's a very interesting thing, because when we look at, there are already startups, at least we know a couple of startups which are working in that area. We see them as a 20 to 30 year transition plan before maybe fuel cells for heavy vehicles will actually become viable, or the Indian economic condition can change. But the economics today in places like India, a lot of countries in Africa, Indonesia, definitely for heavy vehicular traffic, I think, ICE or a mixed combustible hydrogen with a lot of new technologies, amazing technologies have come which actually drop the NOx and the SOx by bringing the combustion temperature lower. These are available. So overall, I would say that a huge volume of entrepreneurs, if they appear in the Hydrogen Valley, or I put it the other way, if Hydrogen Valley is going to nurture a large volume intake of entrepreneurship, that would really set the wheels, the ball rolling for India in the next 10, 20, 30 years. It will be an amazing set of results, because we know that every dollar we invest in India is literally equal to $10 to $20 invested in US as an example to produce the same results. Yeah.
Yeah, thank you. Vasu, do you want to also comment on what are the kind of companies you're seeing that are getting interest, attention in the startup world, especially? Because there have been questions on even in the Zoom and in YouTube about, looks like some things which big companies will do, right? Where are the opportunities for the startups, right? So can you give us some examples? What are the kind of things that are coming up and what excites you? And then I'll ask the same question to Sonisha also.
Yeah, I'll give you 2 or 3 names. One, the ICE that we talked about, one of the companies that we had looked at and we still continue to track is Aerostrovilos, which is actually a multi-fuel engine. That's what they're developing. Actually, they took up a public published NASA technology with direct fuel injection and have developed some amazing low temperature burn, which is around 800 degrees instead of the 1200 degrees, which typically creates a whole material capability issue, but cutting down the NOx and the SOx, because it's not at the high temperature. So this is one example. The other one will be the new trace, which probably many of you may know, which is the hydrogen generation. And this is a technology which they are working on. They've kind of started doing small scale pilot without any membrane at all. There is no PEM or anything, which is a very interesting. It could either become a humongous success or will disappear, which is like a normal thing with startups. These are
Is this
some
for
of the
hydrogen
examples.
production, or is
Sorry?
it for fuel? Is it for hydrogen production?
Hydrogen production with no separator membrane at all.
Okay, great. Sonakshi, over to you. How about some examples, some cases which you think are exciting right now?
Sure. So when I started off that report, probably I could count the number of startups on my fingers. Probably it was 8 or 9. Now in the last 1 year itself, I've met more than 15 or 20 startups that are not mentioned in the thesis. So that's the kind of uptake that we are seeing. I would say my top of funnel has increased by almost 20-30%. But to be honest, the kind of companies that are getting funded are like handful. One of the very few interesting companies that we are tracking is OSIS. So OSIS is a company that's into the biological ways of production. So basically, it has developed a very proprietary layer of biocatalysts. So say if you are a Tata Steel, for example, and you have this entire industry effluents, entire wastewater that comes out of your factory. So what this team has done is they have created a proprietary biocatalyst layer that targets the carbon in your wastewater or in your industry effluents. And this carbon in turn is converted into hydrogen, what we call green hydrogen, because it's completely biological ways of producing. So it's in a way converting your industrial wastewater, converting your waste into probably a fuel for yourself. And these solutions, these biocatalyst layers and reactors can be deployed at your location itself, at the factory itself. And the beauty of this is that if you are a Tata Steel, probably the kind of wastewater that you will get would be very different from, say, if you are a PNG or an FMCG player. So it can be customized for the kind of wastewater or the kind of industry effluent that you are getting. And you can produce hydrogen at a very in a very good certain range. It's not always the best, probably. So for steel or probably say any other effluent, the ranges might vary in terms of efficiency in conversion, but they are pretty nice if we compare it to the industry averages. But that is the entire problem that I was talking about. They have developed this beautiful technology of production, but the consumption is just not happening. So the entire hydrogen that's being produced, that's just useless because they cannot they cannot start using that hydrogen. So these are some of the challenges. H2CO, Hydrovert, of course, these are a few of the other companies that we are tracking very closely.
Sure. Shoma, over to you.
So I think now I would like to go quickly to Satyajit, then we'll come back to Sunisha before she drops off. Yes, that might just switch on. Satyajit, so your entire academic career and past experience has been in battery technology. And as you see the advancements in battery technologies, you can think that probably renewable energy will become much more adaptable, much more common. So in that kind of a scenario, how do you think, like you chose to specifically target hydrogen fuel cell? So what was your thinking behind that? What actually motivated you? If you can comment, but before that, briefly, if you can talk about Hydrovert, what exactly does, so that for our audience to also know about it.
Shoma, a quick correction. Satyajit did his PhD on fuel cells, right?
Yeah, but after that, he has worked at length with battery and does consultation on the battery.
Sure. Good.
So at Hydrovert, we are basically developing hydrogen fuel cell powered drivetrains for applications in the smaller vehicle segment, like motorcycles, three-wheelers, and four-wheelers. And we are mainly focusing on the cargo vehicle segment, where the vehicles get driven a lot. In the day, they have very less time for charging, and they also need to carry a very heavy payload. And we are basically targeting this particular segment because the technology that we are developing is very lightweight for the drivetrain using hydrogen fuel cells. That allows us to give a very long driving range, almost 2 to 3 times of what similar battery operated vehicles would give. And it comes with the inherent advantage of 3 to 4 minute refueling. So we feel that these two factors together are very important and useful for all the cargo vehicles that are being operated on the road today, including motorcycles, which are used a lot by Swiggy, Zomato, all the last minute delivery people who who drive their vehicles a lot but don't have too much time to stop in the middle of the day for 4 to 5 hours of charge. So that is the basic of what we are doing at Hyderabad. And my PhD was in hydrogen fuel cells, which finished in the year 2010 from the University of Florida. And thereafter, I got a chance to work on actually battery technology. And at the core, battery technology and fuel cell technology are very similar because they're both electrochemical technologies. And I spent around 3 to 5 years working in the lab on battery technologies of various types, high temperature batteries, lithium-ion batteries, lithium-sulfur batteries, and so on. And then I had a chance to do a lot of consulting in both hydrogen and battery technologies as well. And so as a part of my career, I got a chance to always compare these two technologies because that is what the consulting required me to do. And since I had a background in fuel cells as well as batteries, so in my mind also there was always a comparison to see which technology is better, what are the advantages of which technology. And what the conclusion that I came to was that both battery technology as well as fuel cell technology, they have certain intrinsic capabilities and advantages and some intrinsic limitations. And so that I always had a desire to work in the hydrogen fuel cell technologies. And so we started thinking that what are the areas where this technology has certain benefits. And we found that when it comes to lightweightness and compactness, so that is where hydrogen fuel cell technology is very potent. Because if you compare at a system level, then with the existing lithium-ion battery technology, the weight difference for a system of the same size in kilowatt hours is around 3 to 4x. And what that means for mobility applications is that you can give that much more range because your fuel cell system is much lighter, so you can pack much more energy on the same vehicle, and so you get much longer range. At the same time, the fueling system is same as a CNG vehicle, and so that means you can have 3 to 4 minute refueling. So that was the basic driver behind wanting to work on hydrogen fuel cell technology. At the same time, things were aligning in terms of the government focus as well. And as we are all aware, in the last 3 to 4 years, the government focus has intensely shifted on hydrogen technologies, what India can do in hydrogen in terms of exporting hydrogen or hydrogen-based products, and how we can use hydrogen to reduce our own dependence on imported fuels. So those were the basic considerations for working on this.
So just I think Sonakshi might leave in a little while, so let me ask her. Sonisha, sorry. Do you want to say? He mentioned a few drivers out there, right, for a fuel cell technology or hydrogen energy. We heard from Ashish also, decarbonization being one, cost effectiveness amongst other alternatives, energy security, lightweight, and various different value propositions out there. Which is the one that would excite you the most?
I'll take another question before that, if I can also be placed. I just want to put Sonisha and Satyajit probably face to face and ask Sonisha, when would you really consider Satyajit for an investment?
Sure, that
do you think you should have, achieved, which will, or I mean, indirectly, basically, what would you really see, consider this as a potential for investment?
that's the most masala-full panel that I've ever been on. So loving it so much. But yeah, so as I said, probably for investors, unfortunately, we are covered. Our capital follows the path of least resistance. So as much exciting as the technology may be to the world, to the founders, and to the entire team, if it cannot get customers, if it cannot make business sense, we would be the last people to even bet on that. So we promote technology all in, all out, but when it comes to committing capital, most of the investors are covered. So probably scalability is one thing that comes on the top of my mind. Number one, scalability. Number two, okay, probably the qualitative aspects of it. Number one would be scalability for me. So generally, scalability is hit when, say, technology hits the commercial tipping point. So right now we talk about that 111 say aim of green hydrogen, but most of the existing solutions that we have offer, say, $2.5 to $3. That is the best that I'm talking about in terms of price of 1 kg of hydrogen. So that way, unless and until it hits that $1.5 to $2 range, which would be the, I would say, the toughest of the legs till date to hit that range, that would be when most of the investors would be excited for an instance. So that way, when we see more and more pilots happening, more and more customers giving you pipeline orders, giving you, say, bigger orders, is something that we would get excited about. We being early stage investors, most of our capital commitments are also dependent on the follow-on investors. If we'll be able to get follow-on investors in the very same segment and for the very same technology, and most of the follow-on investors that we have in the country have a very dhanda kind of a mindset. So unless and until it makes absolute business sense, economic sense, we are unit level positive. We are probably, if not PAT positive, that at least CM2 level positive. That is the ripest case where a follow-on investor would come in. So that ways we have our own challenges that ripple down to us. But yeah, seeing more and more pilots is something that we would, more and more deployments is what we look forward to. Since it's a very grassroots level technology and it's like a completely new innovation that's happening. So of course, post-product pre-revenue is something that most of the investors, at least the early stage investors, have a sweet spot for.
Are there any cases where it's an asset play rather than a revenue play, where there's a technology transaction or an acquisition based on a platform rather than just revenue growth? Because it looks like it will take some time, right? And it is
Yes,
dependent upon how the infrastructure shapes up, how the alternatives shape up.
exactly.
But that also, all that risk also must mean an opportunity to make outsized rewards for some of the
Exactly.
VCs.
Exactly.
Are they thinking about it? Or as somebody
Sure.
in the question said, we're chickening out a little bit in India. Yeah.
Sure. So, I guess this is very similar to, not very similar, but we can draw the parallels from an EV sort of a era that came in India. So the entire market was just, talking about EVs. The entire value chain got parallelly developed. So from batteries to battery manufacturers to probably your Yulu type of companies, then your entire Vecmocon, the tech plays that came in, platform plays that came in, and the entire industry developed sort of parallelly. This is what I foresee for hydrogen as well, because EVs still say easier for adoption. Probably hydrogen would be a bit tougher for adoption, but these are the kind of plays that I think would be happening. So we played a bet called Battery Smart, probably one of the very first checks, and now that company has raised over $70 million in their very last round. So of course, you get the right to make outsized returns. We invested in a company called Carbon Clean probably in 2012 when it was nothing, and now it's a $1 billion outcome for us on at the least. Vecmocon was another company that just focused on product, and probably now is the time that the revenues have just started scaling up like anything. There was another very interesting example called ethereal machines. So that these guys are building 5-axis CNC machines. So for 8 years, they had zero revenue. And it was just the early plus follow-on investors' appetite that kept them alive. And today is the day when they're raising rounds from Sequoia and Bloom and other follow-on investors. And the revenues are just probably actually they are half a $100 million, probably $50 million. So these are the kind of hopes that we as early stage investors have.
Yeah. Before you leave, last point, there's a question about advice for entrepreneurs, including, people not having very clean and open conversations. But anyway, you can give a little generic answer about advice for entrepreneurs and startups. But also, what are your expectations from the government? Since we have Ashish here, and Ashish has an opportunity to perhaps pull some levers out there. What would get you excited about this field? What could be things that could create more pipeline for you, and so on?
Sure. So I would say we investors are trolled a lot for being coward and being not able to support the early innovations. But again, we have to return the capital that we have borrowed, and with probably 40-50% return on capital. So that is the constraint that we private investors live with. The only request, so the cost of capital probably is the biggest cost of innovation that we have in India right now. So if probably government can come in for reducing that cost of capital in any way for our founders, to support the R&D structure. I was just talking to one of the founders, I won't name, in one of the incubators, very well-known incubators in India, and the kind of prices she was paying for a public incubation center just to have one seat, that was crazy. Just because the incubation center had good labs and good facilities. So if we are probably making innovation so expensive at the grassroots level, how do we expect our founders to probably innovate more and more? We have to have 1,000 iterations, but that too very fast. So we should be able to we should be able to make 1,000 mistakes. That is how we learn, and that is how our learning rate would improve. So the cost of making mistakes is just too high in India. And unfortunately, private investors, early stage especially, have been bearing that cost of mistakes. But for such early sectors and early technology, that is something that we can't very openly do, because we have to understand that a hydrogen startup, for example, that has nothing proven yet, it's just pure tech, is competing with, say, probably an edtech startup or a fintech startup that has already 5 million transacting consumers on their platform. So if you present that trade-off to probably an LP who gives us money, the choice is very clear for them. So having more of these R&D setups ready, reducing the cost of capital in some way. I see government doing some steps towards the semiconductors business, for example, providing all these grants for foundry businesses. We still have around 1 billion left for foundry businesses, but that is not the case with green energy, is what I feel. Very specific grants that are rolled out. So these are some of the initiatives that I would really like to see from the public side coming in, so that we could work together.
Great, thank you very much. We won't keep you long. I understand you have a deadline, hard deadline, right? So
Thank you.
over
Thank
to
you
Shoma
so
again.
much.
Yeah,
It was
thank
a
you.
lovely session. All the best, guys. Bye-bye.
Thank you.
Thank you so much for coming here today. Yeah, thanks. We'll catch up again on another platform. All right.
Sure. Bye-bye.
Shoma, we can probably take just a few more minutes if you don't mind, if everybody doesn't mind. I think we got a lot of inputs on the investor side. I'd like Ashish to also comment. Ashish, do you really think there are opportunities for startups? Looks like, and we saw a lot of comments coming up about how it looks like a big boys game. So do you want to comment on where exactly you think startups can do it? Also, where it's early and there's an opportunity to disrupt things.
So I showed two examples where I think the big boys will not come in. Three examples. So one was a clear startup that came out of Australia, and I talked about HiSATA, very high efficiency electrolyzer, right? It has come out of a university. It has come out based on some really nice, really cool science. And now a startup that is raising a lot of funds. So these kinds of innovations, which are really science-based and tackling the right problem that needs to be tackled, is something that startups in India should really focus on. Okay, it is very well known why the efficiencies of electrolyzers are only 70%. Why are they not beyond 90%? It's very well known, right? But how many innovators are really doing deep science, deep tech innovations? Okay, I think that is one thing I would suggest. The second thing is, Vasu talked about offtake, and I completely agree with him. We have to focus on offtake because that gives you immediate revenues, it gives you scalability, right? And two things that Soniksha talked about, where investors would like to invest in, you want to see revenues and you want to see scalability, right? And that requires offtake. So the other thing that I mentioned in this context is the sector which is strategic to India, the fine and specialty chemical sector. None of the big boys will look at it. Too small for them. We're talking of, for example, in Pune Hydrogen Valley, just 2 tons per day. 2 tons per day, none of the Ambanis and the Adanis would be interested. But that doesn't mean nobody is interested. This is a sector that requires smaller amounts of hydrogen. Right? Each company requires a smaller amount of hydrogen, but the aggregated demand is not small. Right? 100 kilotons per annum is not a small amount. Now, the interesting bit is these companies are also, they happen to be located in a geographical area. Ankleshwar, go to Dahej, go to Surat, go to Hyderabad, go to Visakhapatnam, go to Solapur, go to Taloja. These are all industries which require hydrogen, and they are located within 50 kilometers, 70 kilometers distance. And that completely solves the biggest problem, which is storage and transportation of hydrogen. You don't need to, because you make hydrogen where you want it. Offtake is guaranteed. You don't have to worry about storage and distribution. And people are willing to today pay $3, $3.50 per kg hydrogen. So where is the problem? This is a very India-specific offtake assured demand. None of the big boys will pay any attention. This is a great opportunity for smaller companies to step in. Right? So, we have to identify these kinds of very India-specific problems and capitalize on them. Right? So one is offtake I talked about, the other is deep innovation that I talked about. And hydrogen is a great example of something similar. Right? Smaller range of transportation, but there is no time for recharging. I mean, this is again so very India specific. So I think this is what opportunities the Indian startup ecosystem should capitalize. Then the issue of very high capex requirement goes away. Right? Offtake is assured. Right? I think that would be my comment. I just want to also tell Vasu that there is a startup in Nagpur that is already producing very high quality hydrogen sensors. They are commercial. The technology has come from, I think, Oxford. And they are, I think, also exporting hydrogen sensors. Right? And there are some other interesting innovations that are happening within CSIR. I'll be happy to tell you about it. And they are really deep tech innovations. To give you one example, you take a fiber optic cable. You can, on the cable, you can, at a certain frequency, make gratings, very precise gratings, which can measure a few micron displacement. So you take a fiber optic cable and you wind it on a hydrogen cylinder along with carbon fibers, right? It will tell you, it will give you real-time data of what is the expansion of the hydrogen cylinders in microns. Okay, real time. Every time you refill, every time you use the hydrogen cylinder, there is a small breathing of the hydrogen cylinder. It happens. And we can detect it today. I can show you data, we can detect micron size. And what is even more beautiful is there is what is called a compression set, which means you fill hydrogen at 350 bar, the cylinder expands a little bit. As you empty the cylinder, it doesn't come back to its original dimensions. So there is a set, there is an expansion that sets in the cylinder. So you are actually tracking the lifetime of degradation of the cylinder real time. And it can give you early warnings of when the cylinder may leak, when the cylinder needs to be, changed. So a lot of safety related issues can come out of these kinds of sensors. So I agree with you. A lot of exciting discoveries happening in the sensor part. I think you guys should take a deeper look at what is happening, what innovations are happening in the country, and look at investing in them. I think one last comment, Premnath, I would like to make is there is still a lot of disconnect between research happening in Indian academia and investors. That gap somehow needs to be bridged. Not enough is right. The innovations that I talked about have not reached the investors at all.
Yeah. In fact, Ashish, I think I wanted to sort of use that as the last thing, because there were several questions from people on how can they learn more, how can they get involved. So for example, how students wanting to learn more about the field, people wanting to learn more about how, the Hydrogen Valley program and how they can participate. Will there be an open innovation activity, so on and so forth. So maybe we can, if Shoma is okay, we can close on that note and give Ashish an opportunity to talk a little bit about how they, what are the few things we can do, and perhaps also a few things which we can do to bring in more resources into this field and remove some of the hype or the bring out the opportunities in this field, through a little more awareness and discussion, while also keeping the investors aware of all that's happening around us. Last few comments, please.
Yeah, so Prinath, on the Hydrogen Valley, honestly, it's an experiment that we are just about beginning. We really have no clue where it will all go and how it will evolve. What we do know is that the particular problem we are trying to tackle, which is what I talked about, the fine and specialty chemicals, is a very scalable model. Even at 2 tons per day, we believe, and with the technology that we are going to deploy, which is again an innovation, which is a very India-specific innovation, came out of a university. We were able to track it early on. We are able to scale it. That model of utilizing hydrogen where it is produced is a very scalable model for this particular industry. So that is the first target that we are looking at, the Hydrogen Valley. Make it sustainable, financially viable. Beyond that, there are any number of things that a valley can do. It could work as an incubator. It could work as a testing platform, providing services. At some point of time, India will definitely have to have an IS certification, a BIS certification. Every electrolyzer, every internal combustion engine, every hydrogen cylinder, every fuel cell that is deployed in this country must have an IS mark. Today, people are buying and deploying. There is no standardization, there is no testing, there is no certification. That has to change and will change. The reason for that is there is no testing platform in the country today. A Hydrogen Valley can offer a very nice way to create a testing platform like this. This has happened elsewhere outside the country. So, doing it in India is another way for a Hydrogen Valley to grow. So there are multiple directions in which the valley can grow. Honestly, as of now, if you ask me what Pune Hydrogen Valley will do, I'll say I have no clue. We are like a startup. We know what we are going to do today is sustainable. We have a scale-up route, that we see is very, very doable. But we can do many more things other than that. In fact, one of the things we are really looking at is how do we, use the essence of Hydrogen Valley where all technologies are deployed at one place. Everybody will look, they will look at one electrolyzer technology or one fuel cell technology or one storage technology. The Valley offers you a platform to bring all those innovations in one place. Right? And I think that's a very interesting model. It's a very unique model, which I think can grow. And that allows us to look at very India-specific problem. There's one problem we are looking at, which I can guarantee you doesn't happen anywhere in the world, but it's too early for me to talk about it. If we grow on it, in some other occasion, I will talk about it. But there are these very, very unique opportunities for India, which a valley can, build
upon. Yeah.
So I would finish with that comment, Prima.
Yeah, great. Thank you very much. I think we will close on that note. I don't want to, we are about 15 minutes beyond 6 and I didn't want to hold up people. I know there were a lot of questions and we were not able to take some of them up, but I would encourage people to write to our team, Shoma, and there's an online form which has been put up. If you put some things down there, we'll be happy to get back to you as well. And we'll try to get you some answers also if you have some specific questions. Of course, we're very happy to help innovators in whichever way possible. So feel free to reach out to us and we'll try and make that happen. Today, Dr. Vishnu, who is the CEO of Pune Hydrogen Valley, was not able to make it, but we'll be able to connect you to them as well. So over to Shoma. Shoma, if you are okay, we can close now.
Can I just take a little bit of Vasu's time and get some final comments from him as well?
Yeah. Please do.
Yeah, so I just had a question. I think we have heard already some part of it, Vasu, but from your experience, any international practices, successful strategies where you have seen international ecosystem being adopting hydrogen and actually facilitating this whole offtake. Would you like to comment on that? Because you have been also tracking things globally as well. And also finally the advice for the startups that we had asked Sonisha. that if they really need to work in this sector, what they should keep in mind and about the investment opportunities they should target.
Okay, thanks, Soma. I think the second part of the question, I call it a trap question. I'll leave it. I'll answer it a bit later. But on the international one, at least I can summarize in a kind of a high level manner. If you notice, Europe was the one that moved ahead in hydrogen. I mean, in terms of leading, made all the noises, right noises. A lot of action started out in Europe. But actually, what is happening in the last 2 to 3 years is US is beginning to overtake Europe. And it's a very interesting phenomenon, even though we would, US being typically what it is. What is actually driving it is actually related to the point that I made earlier on about, this is actually a request I would like to make to Dr. Ashish Lele about under Hydrogen Valley, which Dr. Premnath was also mentioning, is it's the ecosystem that gets created. The US ecosystem is so powerful with both the government grants and the maturity of what DOE. I mean, we saw the numbers. DOE, what it spends in 1 year, we have spent 1/10 of that over 5 years or something like that. So the ecosystem in terms of the processes and nurturing and the money that flows in, money, yes, there's always challenge. We respect that. But at the same time, we can be very efficient. $1 in India is equal to $10 in the US system. But having this ecosystem, building this ecosystem is critical. This is what is going to allow the future successes to come out, and a bit of patience. Investors like us, we are a little bit different from what Sunisha was talking about, because we tend to balance our portfolio with patient investors. We really look at technology. We try to work with the companies, and we try to balance the portfolio risk of how we can return to the LPs. So there are a few people across the world. US is definitely moving ahead. It's beginning to overtake Europe. Europe is focusing more on regulatory aspects, and the entrepreneurs, the wild spirit in US is proving to be faster moving. And I think that would be the high level statement I would make. On the second point, the point that was made by Satyajit and his company, I don't know too much of the detail, but obviously it requires a lot more discussion, and we have our own ways of approaching, looking at the things. Where is the market and offtake? In his case, it's not so much the market offtake, but I think it's more the economics of why a small vehicle or this cargo vehicles will end up using a very high initial cost, which maybe I'm making an assumption here in terms of fuel cell being of initial high cost thing. That's a separate discussion we can have. It's the economics that has to work out, and the market has to support that. And that's what we look for ultimate success.
Thank you. Thank you so much, Vasu. And thank you so much for taking out time today. And we will definitely be catching up again on another platform or a discussion for some of our startups as well. And thanks a lot for your time today. So I think with that note, we would like to end here, and I would request the online participants to kindly use our feedback form to give us feedback. I'm sure you have learned a lot actually from this event altogether today. And thank you for joining again. And for our in-person participation here, we have a QR code there. Request all of you to scan that code and give us feedback so that we can bring such information-led events for you in the future as well. And yeah, thank you so much. And for our in-person events, we have some light refreshments outside, and you can also interact with our speakers today. Online participants, unfortunately, we are not able to offer anything at this point of time, but definitely next time when you are coming in person, we will be having that.
We'll plan some electronic refreshments next time.
Yeah, I was just thinking some emojis need to be sent out at least.
Thank you very much for the opportunity. I think it was
Some,
wonderful.
Token of appreciation for our in-person panel members here, and hopefully, Vasu, we would be either shipping it to you, or whenever we are meeting in person, we would like to hand it over to you.
No
anyway,
problem.
thanks once again for your time.
Thank you all. Thank you. For such a wonderful session. Thank you. Bye.
Thanks a lot. Bye-bye.
Nishan, can I request you to just hand over the case? So yeah, thank you so much. And as I said, please join us for light refreshments. And if you have any further questions. Yeah, thank you so much. Nisha, yeah, sure. I can put you in touch. If you can just send me, I'll share my card with you. You can send about some details about what is the thing that you wish to discuss. And definitely, I would. You can just drop. I'll share my card with you and just bring it.
Yesterday I was in campus and that went for incubation.
Okay.